Let us take up a lesson in chemistry. The new lesson that we are going to see today is all about metals and non-metals. Children, every day we use many things. As a student, you are using many things. Some of them are your pen, your geometry box, and in the geometry box it has many instruments including protractor, divider and compass, and the table and the chair that you are sitting in the school. So on and so forth. We can go on adding more and more number of items. The things which we are using are called materials. The materials that we use can be classified into two types according to the elements. So elements are classified into two, metals and non-metals. So which are all metals and which are all non-metals? How to identify a metal or a non-metal? All these questions has an answer in today's lesson. Come, let us go into the class for the next slide. Children, let us see some of the metals and non-metals that we are coming across our daily life. Iron bar. So we use iron bars. For example, iron bars plays a very important role in building bridges. Our windows, they have a panel and that is made up of iron. Our almirahs or the safe is made up of iron. So iron has many uses in our day-to-day life, including the locks that we use to protect our house, right? Then electric wires. Have you observed what is there inside the plastic? Yes, exactly. It is copper. Copper wire is a metal. Copper is a metal. And it has a shiny looking, right? We'll see to it later. Then what about the utensils that you are using in the kitchen? Some of them are made of aluminum, right? So aluminum is a metal. Then whenever you go to the doctor, they keep a thermometer to check your body temperature. So what does the thermometer contain? It contains a liquid called mercury. Mercury is the only metal which is in the liquid state. It's a very GK question. Name a metal in the liquid state. The answer is mercury. So mercury is a metal, and the most costly metals are gold, silver, platinum, right? And apart from that, zinc we use in galvanization, and we use railway tracks, the steel bars, right? So we can go on adding like this many examples for the metals that we encounter in our everyday's life. Similarly, non-metals. Most of us are familiar with bleaching powder that we are using in our cleaning purpose, right? So bleaching powder is nothing but it is a non-metal, and the non-metal in it is chlorine. Okay, chlorine is a non-metal. And the ordinary pencils that you use, no, you find the lead, right? We find the black color tip, and that is nothing but graphite, or we can even say carbon. It is a form of carbon, and this carbon is a non-metal, right? And we used to have balloons in Independence Day and Republic Day, and in some functions, balloons filled with hydrogen, and they, what do as because they are lighter than air, they start to fly in the sky. So the hydrogen gas is a non-metal. Not only that, some of our cars and two-wheelers tires are nowadays filled with hydrogen gas instead of ordinary. The atmosphere contains 78% of nitrogen and 21% of oxygen, which are again said to be non-metals. So I have given you a list of metals and non-metals that we use that we use in our life frequently. And the question is, which are all metals? How to identify the metals and how to identify non-metal? It is still a question to be answered, right? So we'll learn it in the coming up slides. Yes, children, go through this slide. You are familiar with a number of materials like iron, aluminium, copper, etc. Can you name the materials which are metals? Metals can be distinguished from non-metals on the basis of their physical and chemical properties. Physical and chemical properties. Now we have reached one point. Metals and non-metals can be identified with the help of their physical and chemical properties. What is a physical property? We will see in the next slide. We have observed that metals and non-metals can be identified with the help of their physical and chemical properties. Now, what is a physical property? Physical property can be observed or measured without changing the composition of matter. Supposing if you are studying about iron, now you can observe the iron and you can do anything without disturbing the composition or the shape. So that particular study is called physical properties. What are the things that we can study without disturbing its appearance? I mean, without disturbing its composition. We can, by just looking at it, we can tell how the appearance is, how the texture is, what is the color of it, what is the odor of it. Odor means smell. What is its melting point? What is its boiling point? And what is its density? Is it soluble in water or is it soluble in other liquids? And these are the things which determine physical properties. So physical properties is just by looking and telling the property without making any change in its composition. So they include appearance, texture, color, odor, melting point, boiling point, density, solubility, etc. Then what is a chemical property? A property or characteristic of the substance that is observed during the reaction in which the chemical composition or identity of a substance is changed. Chemical property is when a particular substance reacts with another substance and gives a new substance is called a chemical property. So this we will study in detail when we go to the chemical reactions. So based on these two, that is the physical property and chemical property, we can able to identify the elements into metals and non-metals. Here is an activity that we are going to do, or even you can do it in your home. So you have to take a small piece of nail, a cold piece, a piece of thick aluminum wire, and a pencil lead. These four things are easily available. So a nail, cold piece, thick aluminum wire, and pencil lead. So what you have to do with all these four? You take a hammer and hammer these four things with a force, one by one, and observe what happens to these four after you hammer. This is the activity, and this activity will result you in identifying some property, and what is it, we will see it in the next slide. So what will be the observations after you hammer these four things? Iron nail, thick aluminum wire, a piece of carbon, and your pencil lead. Obviously, the pencil lead and the coal will turn into pieces on just hammering, even without using a stronger force, isn't it? They change from solid to powdered state. And what happens to the iron nail? The shape of the iron nail will get changed, isn't it? And what will happen to the aluminum wire? The aluminum wire is cylindrical in shape, and after hammering it, it becomes flat. Is it not? It becomes flat. So, by this activity, we can come to the first point. Those which can change the shape on heating, they generally belong to metals. Those who changes the shape, or they break away easily when hammering, then they are called as non-metals. Look at this slide, children. This is the first property which will make you to distinguish a metal from non-metal. You see the figure given above. So the pipes are very shiny, isn't it? They are shiny, and next to it is a coal. And how about the appearance? Do they shine as the pipes are shining? No, definitely not. They are dull. So these pipes are made up of a metal. So generally metals are lustrous. What do you mean by lustrous? The ability to shine is called lustrous. Metals are lustrous. Non-metals do not have a shiny surface like metals. Then metals are shiny in appearance, that is it. We call it as lustrous. But non-metals, they are usually dull in appearance. So on the basis of this, we can tell gold, is it shining? Yes, it is a metal. Silver, is it shining? Yes, it is a metal. Copper, is it shining? Yes, it is a metal. Now at the same time, coal, is it shining? No. Then it belongs to non-metal. Carbon is nothing but the pencil lead that we have already seen in the previous activity. That is non-metal. Then sulfur is a powder, and it itself is a powder, but when you look at the sulfur, I will show you when you come back to the classes the sulfur powder. from the laboratory. So that too is not shiny. So generally, what do we conclude from this first property, appearance? Those which have a shiny looking, those which are lustrous, they are said to be metals. On the other hand, those materials which do not have a shiny surface and are dull to look at, then they are non-metals. So the first basis, on this basis, we can classify metals and non-metals. Here is another activity to distinguish between metals and non-metals. We have to take a small battery that you use it usually in the remote controls, and actually it is with a different potentials, so it will continue to supply current. Okay, and in that you will find a plus and minus. So those plus and minus are the terminals, and you have to connect a bulb and two wires, leaving a gap as shown in the activity. So through the plus you can connect a battery, through the plus you can connect a bulb, and from the bulb you can take a wire and leave as it is, and from the negative take a wire and see to it both the wires are not touching, that is the green wire and the red wire are not touching. Now in the gap between the green wire and the red wire, you place those four things which we have discussed in activity 1. First, keep a iron nail. Now what will you observe when you connect a iron nail? We can see the bulb will glow. That means there is a continuity of current in the circuit. So what we can conclude then? Iron is a good conductor of electricity. Then next you keep the aluminum wire in the gap. What can you observe now? Here also, in this we can observe the bulb glowing. So we can conclude aluminum is a metal because it is a good conductor. And when you connect the carbon or the pencil lead in between the red and green wire, you cannot see the bulb glowing. The bulb will not glow at all because there is no continuity in the current. That means it is a bad conductor of electricity. So what can we generally conclude from this experiment? Metals are good conductors of electricity, and non-metals are poor conductors of electricity. Those who conduct electricity are metals. Those who do not conduct electricity are non-metals. This slide gives you the observation of the previous activity which you have done. So when you connect the iron nail, copper rod or aluminum rod, the bulb glows, indicating that they are good conductors of heat. And so we generally say metals are good conductors of electricity. When you connect coal or sulfur in between the gaps, then the bulb doesn't glow, indicating that it is a poor conductor of electricity. So those which conduct electricity are good conductors, and those who do not conduct electricity are poor conductors. The next property we are going to discuss here is called sonorous. What do you mean by sonorous? The ability to make sound. Sonorous means the ability to make sound. See the pictures which are given in this slide. It contains bell as well as an instrument used in the musical orchestra. So all this, when being hit it produces sound. So generally we can say metals are sonorous. This means they produce a ringing sound when hit. This property allows it to be used for making bells. On the other hand, the nonmetals, sulfur, phosphorus, carbon, these, however much hard you beat them, they try to convert themselves into powder, but they do not give any sound. So, in general, nonmetals are not sonorous. They are brittle. What do you mean by brittle? When you hit, they break very easily. So, by this property, we can identify a metal or non-metal. If you hit, it makes a sound, then it is a metal. If you hit, it breaks and doesn't make a sound, then it is a non-metal. Now, let us see the property called malleability. It's called malleability. What is malleability? The property of a substance that describes its ability to be bent or hammered into a thin sheet without breaking is called malleability. So if you beat a metal or hammer a metal, and if you can produce thin sheets, then that property is called malleability. You would have seen the aluminum foils which is used for packing up your food substance. So it is made into thin foil. So it is the property called malleability which has been changed into this shape. So aluminum is very malleable, and that's why we use it to make foil to wrap our food. Other substances like glass, it's a non-metal or not malleable because it would break instead of changing the shape. Wood, of course, it's not malleable. Well, copper is malleable, as I have told you. Copper can be made into thin sheets, and gold foils. So almost all metals are malleable. That means they can be beaten into thin sheets. Next, we will move to the property called ductility. What is ductility? The definition says the ability of a metal to be pulled into thin wire or band. It is called ductility. So, the ability of a metal to be made into thin wires is known as ductility. For example, if you open up the wires, ordinary wires that we connect various electrical equipments in our houses, you will see copper wires which are all very, very, very thin inside it, isn't it? So, this property of making a metal into thin wires, it is called ductility. So generally all metals have the property ductility. Not only thin wires, a band, for example, the golden ornaments, for example, your ring, it is combined with copper. Gold is combined with copper, and it is made into desirous designs. So almost all metals have the property ductility, which means which can be made into thin wires or it can be bent in the form of a band. Children, this slide gives you the result of all the experiments which we had done, and now we can clearly understand which substance are metals and which substances are non-metals. So just we will go through the slide. After performing all the above activities, we say that some materials are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. The materials which generally possess these properties are called metals. The examples of metals are iron, copper, aluminum, calcium, magnesium, etc. In contrast, materials like coal and sulfur are soft and dull in appearance. They break down into powdery mass on tapping with hammering. They are not sonorous and are poor conductors of heat and electricity. These materials are called non-metals. The examples of non-metals are sulfur, carbon, oxygen, phosphorus, etc. Okay, children, now you got the difference between metals and non-metals on the basis of physical properties. All which we had seen are related to physical properties. Now, let us sum up what are the characteristics of metals. It's a very important 3-mark question. Metals are all shiny, that means they are lustrous. Metals are malleable, that means they are flexible. Hammered into thin sheets, that means it is ductile. Good conductors of heat and electricity. Most of them are solid at room temperatures. And metals, they tend to lose electrons. This is a very unique property of metals. This property we will discuss when we go to the chemical reactions. So these are the characteristics of metals. Here we have another slide which describes the characteristics of non-metals. Characteristics means physical properties. Non-metals may be solids, liquids or gases. So if you want example, solid, carbon is a solid form, sulfur is in solid form and bromine is in liquid form. So another GK question, name a non-metal which is in liquid state. The answer is bromine. And most of the non-metals are gases like oxygen, hydrogen, nitrogen, etc. So in general, non-metals occurs in all the 3 states. Non-metals are soft except diamond. So diamond is the hardest substance which is ever known. This is another GK question. Okay, except diamond, all non-metals are soft. Non-metals do not have luster. They do not have the shining appearance except iodine. Iodine is a non-metal which is lustrous. Again another GK question. Non-metals are not malleable. They cannot be made into wires. Non-metals are not ductile. They cannot be made into thin sheets. Non-metals which are solids and liquids have low melting points. Non-metals which are solids and liquids have low boiling point. Non-metals are bad conductors of heat. Non-metals are bad conductors of electricity except graphite. Non-metals are not sonorous. So these are the properties, or in general we say characteristics of non-metals. Uses of non-metals. Iodine is used as an antiseptic. Oxygen is essential for all human beings for respiration. Sulfur is used for making firecrackers. So the crackers that you are bursting during the festival of Diwali, they contain a chemical called sulfur, the shiny one. Phosphorus is used in matchbox. The red tip that you find on the matchstick, that is made up of phosphorus. So phosphorus is used in matchbox industry and fertilizers. Now let us see some of the uses of non-metals. Sulfur, it is used for making sulfuric acid, salts of metals, etc. Oxygen is used for respiration by living things, burning of fuels, etc. Nitrogen, it is used for making ammonia, which is used for making fertilizers. Hydrogen is used for making ammonia, which is used for making fertilizers, as fuels in rocket, for welding, etc. Chlorine, it is used to kill germs in water. Iodine, it is used as tincture of iodine, which is an antiseptic. So these are the various uses of non-metals. Now let us see some of the uses of metals. Iron, it is used for making pins, nails, nuts, bolts, tool machines, construction of building, bridges, etc. Aluminium is used for making utensils, wires, furnitures, parts of aircraft, vehicles, machines for packing food and medicines, etc. Copper, it is used for making wires, vessels, electric gadgets, etc. Gold is used for making jewelry, coins, medals, etc. Silver, it is also used for making jewelry, coins, medals, etc. Platinum is used for making jewelry, electrical gadgets, plugs in vehicles, etc. Sodium, compounds are used as common salt, chemicals, etc. Calcium, compounds are used for making cement, glass, etc. So these are the various uses of metals. That's all for today, children. So we have come to the end of today's lesson. So we have studied about the physical properties of metals and non-metals and how to identify if given a metal or non-metal. So with this we come to the end of this today's learning, and as usual you have to, after viewing this, you have to give response. Viewed PPT with audio and send it to the group. Viewed PPT with audio, you send it to the group as you have seen the and understood the concept, right? And the next, I have given you a word file. The word file contains the description